Hello, today in this video, we're going to start talking about ways to find the solutions to quadratic functions. Now we know that when we look at a graph, the solutions are on the x-axis, the x-intercepts. The question is, how can you find those solutions if you don't have a graph? Like if you're just looking at the equation, how can you tell where the solutions are? So the first way that we're going to talk about is the zero product property. And this way works really well if the function is in factored form. So in order to use a zero product property, you need to make sure that the function is in factored form. This property, the zero product property, it uses the fact that anything multiplied by 0 equals 0. For example, 5 times 0 is 0. 1,000 times 0 is a 0. 1 times 0 is 0. 0 times 0 is 0. Anything, if you multiply it by 0, the answer is going to be 0. So that's really the basis of the zero product property, is right here. Because remember, the solutions happen at the x-intercepts when y equals 0. So that's going to be really helpful for us. So let's look at this first example and we'll kind of see how the zero product property works. In this example, we have a quadratic function in factored form, okay? X plus 3 times x minus 7 equals 0. The reason that we make it equal to 0 is because we want to find when y equals 0, the x-intercepts. So usually it would say like equals f of x or f of x equals. But here, because f of x is the same as y, we're going to make it equal 0 because that's where the solutions are going to happen. Because they happen at the x-intercepts when y equals 0. So whenever you're finding the solutions to a quadratic function, the first thing you want to do is set it equal to 0. Then we're going to use a zero product property. Now we know that anything times 0 equals 0. We have two things multiplying each other right here. We have x plus 3 and we have x minus 7, and those two things are multiplying each other. If you want, you can put a little dot in between them to show that they're multiplying. So that means that if this is 0, or if this is 0, the whole thing would equal 0, because this times 0 would equal 0, or 0 times this equals 0, because anything times 0 is 0. So then we just have to figure out what value of x would make this first thing equal 0. Well, if we're not sure, what we can do is we can say, okay, let's take x plus 3 and we'll just set it equal to 0 and see what it is. So x plus 3 equals 0. Subtract 3 on both sides because we're solving for x, and you get x equals negative 3. And that makes sense because negative 3 plus 3 would be 0. 0 times whatever that is, doesn't matter, equals 0 because 0 times anything equals 0. So if x is negative 3, this is 0, which makes the whole thing equal to 0, and then we know that it's a solution because the solutions happen when y equals 0, when the function is at 0. So that means that one of our solutions is negative 3, because that's what made this first term equal 0. The other solution would happen when whatever makes this term equal 0. So what would make x minus 7 equal 0? You might be able to do that in your head and just say, oh, well, a positive 7, because a positive 7 minus 7 would equal 0. If you couldn't do it in your head, you can just set it equal to 0, add 7 to both sides, and then you got x equals 7. So that means that if you were to graph this function, it would cross the x-axis at two places, at negative 3 and at 7, and those are the two solutions, because those are the two values that would set this function equal to 0. So let's look down here. In this we have, again, it's in factored form. We have this factor times that factor. We set it equal to 0 because we want to find the solutions. So if we want to find the solutions, we need to find which values of x will end up setting this function equal to 0. So let's look at the first factor. What's going to make, oops, sorry, you couldn't see it for that whole entire thing. There we go. So if we look at this first one, we have two factors in factored form, and it's equal to 0 because those are the solutions. Now we have x minus 5 is the first factor, 2x plus 3 is the second factor. If either of these two factors are equal to 0, then the whole thing equals 0 because anything times 0 equals 0. So what would make this first factor equal to 0? If we weren't sure, we could just say x minus 5 equals 0 and then solve it for x. So we would add 5 on both sides and you get x equals 5. 5 minus 5 would equal 0. 0 times that equals 0 because 0 times anything is 0. So that works. Again, you might not need to write this out. You could just know, well, I know that 5 minus 5 equals 0, so I know that x would have to be 5. This one, you might want to actually do the equation. So we need to figure out what x has to be here to be 0. So we'll say 2x plus 3 equals 0. And then we're going to see what would x have to be to make this factor equal to 0. So we'd subtract 3 on both sides. We're just solving the equation. So you get 2x equals negative 3. Divide by 2 on both sides. And you get x equals negative 1.5. So that means if you were to graph this function, the two spots where the function is equal to 0 would be at 5 and negative 1.5. Those are the two spots that cross the x-axis because they happen when y is 0. They cause y to be 0. And so those are the two solutions. So using the zero product property is a really nice way to solve or to see what the solutions are when the function is in factored form. A lot of times you can do it quickly. You can probably do it in your head. Like for example up here, well, I know that negative 3 would make that 0 and a positive 7 would make that 0. So the two solutions are negative 3 and 7. You can do it pretty quickly like that, which is nice. So yeah, if the function is in factored form, use the zero product property to find the solutions. Go ahead and try the practice, see how you do. And remember, if you have any questions, you can always email me. Thanks.